Now, before we talk about something else, we also always have to do, with systematic search, we always have to do local search, right? That's the rule in our traditional AI. Local search is so dear to my heart, right? So we have local search algorithms. Again, local search algorithms always work in complete truth assignments. Typically, we have many such solvers. You can develop your solver. It will take a full assignment. It will change some variables. That would be a neighborhood function. You want to have objective function, so that will be how many clauses are satisfied and how many clauses are unsatisfied. And you will use some kind of a hill climbing with random walk, or hill climbing with random restart, or something like that. So with random walk, it would be something like, with probability P, flip any random variable in an unsatisfied clause. With probability 1 minus P, pick the best variable in an unsatisfied clause, where best would be defined as one which minimizes the number of unsatisfied clauses. If you have a SAT encoding of n queens, the best DPLL algorithm can solve up to 700 variables problems, but best WalkSAT algorithm can solve over 100,000 variable problems. And again, these are, sorry, not we haven't described WalkSAT, but best local search algorithm can solve upward of 100,000 variable problems. And this particular algorithm that I just showed you is called GSAT. Okay. Now, we will also talk very briefly about the WalkSAT algorithm. It's a nice algorithm. And it comes from the observation that, let's say we define this notion makes, that I made a flip. When I made a flip, some false clause became true and some true clauses possibly became false. The number of false clauses that became true is the makes function, and number of true clauses that became false is the breaks function. And whenever we make any flip, let's say we go from a full assignment S1 to an assignment S2 by flipping X, then actually what has happened is the number of make S1X, some formulas have been made and some formulas have been broken. So number of unsatisfied clauses in S2 are number of unsatisfied clauses in S1 minus how many clauses it made plus how many clauses it broke. Everybody with me so far? Now, we will use two ideas to refine GSAT further. One idea is, if a choice breaks nothing, it's a good choice. That's obvious. Even if it makes only one thing, if it breaks nothing, it's a good choice in terms of greedy hill climbing. And then second idea comes from an observation of how these algorithms work. The observation is that when you are close to the local optimum, when you have set some variables in a specific way that your number of unsatisfied clauses is small but they are tightly constrained, then every flip makes only one clause. Typically, if there was a flip that made many clauses, you would have done that flip long time back, usually. So typically make count is 1, and so the only thing that matters is the break count, how many it breaks. So the WalkSAT algorithm works like this. This is sort of like a simulated annealing algorithm. In simulated annealing, we had the temperature. It's not like that, but in simulated annealing, we used to pick a variable randomly, pick a move randomly, right? So in the same way, we will pick a clause randomly. So let us pick a random clause, but we don't pick a random satisfied clause, we pick a random unsatisfied clause. So let's say we pick a random clause C, which is false in the current state. Now for this clause, we go over all the variables in the clause. So for each x, each variable x, we compute break of x. We basically compute, if I flip this variable, how many clauses will it break? And now if there exists a single variable or some variable with break of x is equal to 0, what do? We just flip that variable. Yeah, nothing is getting broken, so who cares? Only something positive is going to happen with this flip, nothing is going to break, so let us make that move. So if there exists something with break x equal to 0, then variable has been, x has been flipped. Else we do a random walk. So we do something with probability p and we do something with probability 1 minus p. With probability p, we do a random move. That means we pick a random member from this x and flip it. And with probability 1 minus p, we pick the best member x, best defined with it breaks minimum things, and flip that. This is my WalkSAT algorithm. And of course, we can put everything inside a random restart loop. So then after some time, it will say, you have been searching in this hill for far too long, jump to a different hill. And it will have some parameters like what is the probability of random walk versus greedy move, how many max flips do you do before you do a random restart, how many restarts do you do, etc., etc., etc. Now, there are some natural advantages of WalkSAT over GSAT. Can you guess? So this is the WalkSAT algorithm. It first picks a clause, then looks at only the variables in that clause, and then either takes a good variable and makes a move, or takes a random variable and makes a move. Whereas GSAT did this. GSAT said that with probability p, I will flip some variable in an unsatisfied clause. So I will take a random clause, pick any random variable and make a move. With 1 minus p probability, I will take the best variable in any unsatisfied clauses. So I will go through all unsatisfied clauses and then I will pick the best one. So why might WalkSAT be better? If there is no breaking, then there it is. Okay, so if there is a variable which breaks nothing, in the case of WalkSAT it would do it definitely, but in the case of GSAT it will do it with probability p. That's not exactly true. Why is it not exactly true? Because first we have picked a random clause here. We are not going over all unsatisfied clauses, and actually that is the strength of WalkSAT, believe it or not. So the strength of WalkSAT is that the number of evaluations is very small per move. Why? Because I am not going over all unsatisfied clauses and finding a variable that has the best characteristics, which would be more greedy, right? It would be more taking a better move, but you will have to do a lot of computation. See, when in doing local search, it is important that each move is done extremely fast, so that I can do a lot of search quickly. So because it does not iterate over all variables, it does not iterate over all unsatisfied clauses, you only iterate over variables in one sampled clause, therefore the number of evaluations is extremely small per move, possibly at the cost of the greedy step, but it still makes one unsatisfied formula clause true, which it needs to make for all the clauses. So it's not clear that that makes a mistake or that's not a good idea. So WalkSAT is guaranteed to make at least one false clause true even in the random walk step, and the number of evaluations is extremely small per move. So therefore in practice it was found that WalkSAT is a much faster algorithm than GSAT, and therefore WalkSAT became the de facto standard for solving SAT formulas using local search. Now this sort of ends your chapter on logic.